started to say, this should look familiar. We've been over this quite a bit before. And let's put some motor sizes in here. Let's make this a 5 horsepower motor. Let's make this one a 10 horsepower. How about a 20 horsepower and a 50 horsepower? Okay. Let's look up the FLAs. Where would we find the FLA? 230, 250. Somebody's going to ask me the voltage? Good job. All right. So we're going to assume that this thing is 240, 240. What does that mean to you? It's a delta supply. Okay, 240, 240. Also, we need to pick some other things, don't we? We need to pick motor starters. Is there an 8538? Okay, we're going to use motor starters 8538 type. What else should we select? Wire type. How about XHHW, which is a 90-degree wire, right? And let's select an equipment terminal temperature rating for once. We've been doing always no temperature rating, right? We're going to pick a 75, the equipment, all the equipment, rated. $75 degrees centigrade, okay? And we're going to use EMT only. What does that mean? If it won't fit in a 4-inch, we're going to have to run parallel conductors, right? Can we do that? Absolutely. As long as they're the same material, the same insulation jacket, the same terminations, the same exact length, the same exact more or less resistance, the same type of conductors, copper or copper clad instead of a couple of coppers and a couple of aluminums. We've got to have the exact same type wire inside to outside. Everything's got to be exactly the same more or less, right? As much as possible. Everybody with me? Okay. And we're going to say that our main circuit breaker here is, let's say, a 600 amp circuit breaker. Is there such a thing as a 600 amp circuit breaker? We have to look in 240.6, don't we? Let's go to 240.6. There is. Amazing, I tell you. Okay, let's go back to 310.16 and let's look at our conductors. And is there a conductor that will fit our ampacity that we want to be able to carry, 600 amps? Is there a 600 amp single conductor? Go to 310.15 B16. 310.15 B16. It's been 310.16 for the last 40 or 50 years, and now they got a wild hair and changed it to 310.15 B16. It irritated everybody across the country all at once. It's hard to do that. Okay, so is there a conductor that will carry 600 amps? At 75 degrees. Okay, now what size wire is that? One more time. 1500. Okay. Now the reason I mention that is because we now want to go back to our first conduit table and conductor table, which is in Annex C, I believe, and it's table 4. Let's go back to Annex C, table 4, and I'm going to hit pause while we look for that. All right, so we find that not only is there a wire that will carry the 600 amps, but we could get it theoretically in a 3-inch EMT. Legally speaking, if we have a code question about what size conduit is the minimum size is 3-inch, because we could put 4 600s Wait a minute, we looked up 600. We wanted to look up 1500 kcmil. Someone gave me some bad information. Okay, so 1500 kcmil wires, 3 of them will fit in a 4-inch conduit. So we're fine. So that's what's going to come into our auxiliary gutter. We're going to have 4-inch EMT. What's going on here? What the heck? Okay. Well, I don't know what's going on there, but okay. I'm not going to... Oh, look at my numbers. Where'd my numbers go? All right, let's go back and got to do a little bit of maintenance here. Hang on. All right, so we have 1500 kcmil coming into the auxiliary gutter. What size conductors do I have for my 5 horsepower? What is my FLA for my 5 horsepower motor? Let me hit pause while we get our FLAs up. Okay, to fill some things in the first motor we have number 14, which is good for 20 amps. In the second we have number 10 wire, which is good for 33 amps. In the third motor we have number 4, which is good for 85 amps. And in the biggest motor we have 2-aught, which is good for 175 amps. And now we need to look at, if that's true, what size conductors are coming into our auxiliary gutter. And we're going to assume they're all 9 feet, so they're all under the 10-foot tap rule. So that means that our 10-foot tap rule minimum is 60 amps, and that's the number 6 at 65 amps. So over here, we're going to have to put in number 6, which is good for 65 amps, because our tap rule minimum is bigger than our actual load. And then in the second one, our tap rule minimum is still 65 amps, but our conductor would have been a number 10. So we've got to put in number 6 again. And then the third one, number 6, would not be big enough to do this, or would it? No, not at 67.5 amps. We need a number 4 at 85 amps. So this is going to be a number 4 at 85 amps. Okay, and the last one, of course, we have to go with the load conductors, which are 2-aught, and they're good for 175 amps. Okay. Now we did that to do this. Now we've got some wires going into our auxiliary gutter, right? Now, you know from the lab class that the motor conductors are not the only thing going in there, right? We have some control wires, yes? Okay, let's look at what we have. Okay, we're going to assume, by the way, that we're going to do control transformer, and we're going to take the power out of the biggest starter. And so down here in this starter, we're going to have a control transformer. And so because of that, first of all, we're going to have a pair of control wires going to go to every starter for control circuits, right? So we're going to have, now, we have to make a decision. Are we going to have junctions in the auxiliary gutter, or are we going to have single wires going through? Because it's going to affect the fill of the auxiliary gutter, isn't it? Not very much. It's going to affect the fill, but not very much. So we can put junctions in the auxiliary gutter. So we're going to take a hot and a neutral, because we're grounding one side of the transformer, so we have a neutral side of the transformer on the control transformer, right? So we have 2 wires coming out of there. Everybody agree with that? So let's say that we have 2 wires, and of course they can be number 14, so we're going to splice them right here, and we're going to take 2 more wires down into here, and we're going to splice them again and take 2 more wires down into here to supply our control power. So now we have two number 14s in these conduits, this one and this one, right? And we've got it in our auxiliary gutter. So we've got two number 14s here. We've got two number 14s here. We've got two number 14s here. I'm assuming that we're going to use number 14s, although legally we could fuse the control transformer smaller and use a smaller conductor. As I've said, some people do that. I don't want to carry a roll of number 18 or number 16 around in my truck just to have those control wires. Then I've got to carry around a stupid little 6-amp fuse. I've got to carry all this extra crap for nothing when I can just carry number 14. I'm going to be a lot happier, right? Okay, so I've got 14 on my truck anyway, so I'm going to use 14. And I've got wire nuts so I can splice them here, right? So now for box fill, now you've got to go back to the first semester. Way back to the first semester with Mr. Robinson or Mr. Burke, whoever he had those classes with way back when. And you have to look at box fill. Remember, we're doing auxiliary gutter fill, right? And when we splice wires, each wire that comes away from that counts as one wire. No, not again. Ooh, I thought it was going to destroy itself again. Not that, anything but that. Anything? Destroy it. Hang on. All right, we had an in-class question that didn't get recorded, and that was, can we put splices in the auxiliary gutter? And what I started to say is that very often once you've started an electrical project, that's just the beginning. And because of that, the code always says that you must always allow for expansion, right? So you always put a little bit bigger box than you need, a little bit bigger pull box than you need, a little bit bigger auxiliary gutter than you really need, especially auxiliary gutters, because you put 4 motors in here and then next year or the year before after that, the owner comes back and says, I'd like 4 more motors in that same room, and I think you have big enough supply wires to do this whole thing, so just take them out of that auxiliary gutter. Well, I'm going to have to take everything apart because I've got the wrong size auxiliary gutter in there. That's not a good thing to say, is it? So you want to allow for some expansion. Now, what we're going to look at next is we're going to look at box fill. Back in first semester, you looked at box fill, and the auxiliary gutter is the same way. When you splice a wire in a junction box, right, if you pull it straight through, if you pull 2 wires straight through a junction box, how many wires does it count as? 2 wires. But if you pull 2 wires in and pull 2 wires from another direction and you splice them together, they count as 4. That's correct. Very good. So let's look at our transformer wires coming out of our far right motor starter, and we now have 2, 4, 6, 8 more 14s in the auxiliary gutter. Would everybody agree with that? Now, my other question is, don't we have any control on these motors? Are we going to just run them by hitting start? No, we're going to have start-stop stations someplace, right? Maybe float switches, maybe this switch, maybe that switch, maybe this switch, maybe a pilot light, maybe this, maybe that, right? That's all wires that are going to go somewhere, right? Let's talk about the first motor. Let's say that we want to be able to start that motor from one side of the room and run across the room and stop it from the other side. So we want a start-stop station on each side of the room. That's all we want. We want to be able to start it from over there, stop it from over there. Is that okay? Okay, let's put a start-stop station over here. We're going to put another start-stop station in here. And how many wires do I have to wire 2 start-stop stations? Okay, so let's assume that we can do 2 start-stop stations with 4 wires. Okay, so I lost my start-stop station out here. I don't know what happened to it. Poor thing. And we've got 4 wires going back to the very first starter, right? So now we've got 4 wires in here in our auxiliary gutter, and we've got 4 more 14s in here. What is this thing doing? Okay, so now I've got 2 sets of start-stop stations. Okay, so let's just say that we're going to have our other set of start-stop stations. We have 2 more start-stop stations, and it's going to go into our second motor down to the starter. So we've got 4 more 14s. We've got 4 more coming into the auxiliary gutter. Everybody counting that? Everybody see it? So anyway, let's say that we're going to have a similar setup for the last 2 motors coming off the other side. And we're going to come over here with 2 start stops. And we're going to assume that we can do that with 4 wires. And we're going to have 1 more set of start stops. And they're going to go into our big motor starter. So we've got... So now in each one of these motor branch circuit conductors, conduits I should say, motor branch circuit conduits, we've got 6 more number 14s for control purposes, right? So our conduits might have to be a little bit bigger than if they were just the power conductors. But also, what's going to be affected also? Our auxiliary gutter. So now when we do our spreadsheet for our auxiliary gutter fill, we're going to have, first we're going to have our feeders. So we've got 3 1500s, right? Plus we have 3 number 2/0s for the big motor. Plus we have 3 number 4s for the 20 horsepower. And we have 6 number 6s because we've got 2 sets of 3 number 6 for each of the first and the second motor, right? Now, is that all the wires we have to fill our auxiliary gutter with? We've got, in each one of these, we've got 6 number 14s. Is that correct? So 6 times 4, 24. Is that correct? So we've got 24 number 14s. Would that affect the auxiliary gutter size? Absolutely. And so that's something you have to consider when you're sitting down to design this thing, to order the material to do this job, right? So I want you to calculate the minimum cross-sectional area of that auxiliary gutter right now. And we'll put this thing on pause until we can figure this out. Okay, so we find that the auxiliary gutter's got to have 38.17 square inches or more, right? Now, if we're ordering material, and we would be, right? We want to know, if we're using square auxiliary gutter, what is the minimum size? So we're going to take 38.17. We're going to take the square root of that. What is the square root of 38.17? So 6-inch square auxiliary gutter would not work, right? Okay, the next size up is not 7 by 7. The next size up is 8 by 8. So we would select an 8 by 8, and that would give us a little room for expansion, right? Okay, how many square inches is 8 by 8? You think it's 64, possibly, maybe? We're going to pass third grade math, is that right? Okay, cool. All right. I love that show. Are you smarter than a third grader? Is that, or fifth grader? Yeah, those fifth grade questions are tough, man. All right. So, what am I trying to tell you here? Will you always just have two start stops? No. What if we wanted an indicator light for two indicator lights for each motor, for when it's running and when it's stopped? When it's running, we want a red light on. When it's stopped, we want a green light on. That's counterintuitive. I understand totally. But some motors run into the exact frequency so that it looks like they're sitting still. That means it's not safe to walk up and touch it, right? If you touch it, it might get jerked across the floor very suddenly, right? So you want to have a red light on it saying, not safe to get near this thing. Leave it alone. Back away. Red light, red light, red light. Stop where you are, right? Now, does it make sense? Okay. So you got to remember the light system is a safety system. Green light, it's stopped. It's not running, not green for it's going. No, it's red light, it's running. Don't touch it. Okay? And we might have those coming for each one of these motors, right? Where would those wires have to go to? The motor starter. This thing down here, right? So we would have to take the indicator lights, the pilot lights, down there. How many wires do we have to take? 3 for 2 lights. Very good. And what do we need to add to our auxiliary? What do we need to add to our starter? When we order our starter, we need to add an auxiliary normally open contact. And you can order that just by saying, and I want an auxiliary normally open contact. Boom, you get it. Okay, it's on the holding contact is on the left. The auxiliary contact will be on the right or below it, depending on what type it is. Okay, so we can get some extra control stuff in our motor starter and do different things with it. So think about how that affects our auxiliary gutter and our conduits. Our conduits start getting bigger, right? Now, one more thing. What if we have both these motors, the 5 horsepower and the 10 horsepower? Let's not do that. I know what just did that, but undo that. If we had our 5 horse and 10 horsepower motor, and let's say we put an auxiliary gutter below these two motor starters, and we took a single conduit to feed both these motors and ran out across the room and then put a conduit to split the conduits and took the wires to 2 different places, but we went out of the area from the starter with 1 conduit. What size conduit would we need to put 3 10s and 3 14s? If we go the other way and we take 20 horsepower and the 50 horsepower and we take those motor branch circuit conductors out to an area away from the starters, and we want to take them in 1 conduit, what size conduit would we need to supply 2 number 4s and 3 number 4s and 3 number 2/0s? You see what I'm saying? There are more things we have to kind of calculate out. Okay? All right, that's it for today, and I hope we've learned a little bit, and thank you very much.